Welcome to Mobile World Congress 2024. I'm Michael Dieudonné, an R&D manager at Keysight Technologies working on the 6G program.
My name is Sebastian Kammerer. I'm a senior research scientist at NVIDIA, and in this demo we show you how you can bring machine learning into physical layer signal processing, and we will show a live demo of a live O-RAN test bed where we have an AI-native neural receiver embedded in a site-specific environment.
This work is a joint project between NVIDIA and Keysight Technologies. The research work is done in the context of an SNSJU project called Centric, with the support of 6G Sandbox.
When we look at the classical signal processing of a classical communication system, we typically have a channel estimator, a channel equalization, and then we have demapping and decoding. Now, the idea of a neural receiver is actually that we start to replace blocks of these signal processing chains here by using neural networks. In particular, we are replacing channel estimation, channel equalization, and demapping by a single neural network, and then we train the network to fulfill the same task.
Let me introduce you to our setup. We have a Keysight VXG. The VXG creates a signal which you have two user equipment that are connected to the PropSim. The PropSim is our channel emulator. The PropSim will transform the signal from a MIMO system to 2x4. We have a Lighton commercial ORU, which is connected to the PropSim. The ORU is connected to our ODU emulator. The ODU emulator keeps the link alive between the ORU and basically the core network. In the ODU, we extract basically the IQ samples which are given to the NVIDIA GPU where the AI processor is located.
The neural receiver is implementing using NVIDIA Shona, a link-level library which has support for AI-native signal processing using TensorFlow. So we have implemented the neural receiver and deployed it here in this test bed and show the performance in a site-specific environment. Site-specific means that we can simulate the physically accurate electromagnetic wave propagation in a specific environment. In this case, we are showing the performance, or we're evaluating the performance in the area of Barcelona of the Mobile World Congress. So we have actually loaded the OpenStreetMaps database, so you see the entrance hall of the MWC area and you see the hotel towers in front of the venue here. We assume that we have placed one antenna or the base station on top of a hotel tower, and then we let the users walk around in this area. So we are using ray tracing to get the exact channel impulse responses, which we then load on the PropSim channel emulator. Okay, let's talk a bit about the training of the neural receiver. So we pre-trained the receiver on a huge variety of different channels using 3GPP compliant stochastic channel models. In particular, we're using the urban macrocell environment. That means that the neural receiver has seen many different channel realizations and is quite robust and universal to many different channel environments. After doing this training, we do fine-tuning of the neural receiver, which means that we are using the ray tracing-based channel simulations to train our neural receiver on the specific environment of the Barcelona MWC area. This includes all of the channel characteristics and statistics, such as the delay spread and also the user mobility. Then, if we also sample from the actual test bed, we can also account for hardware impairments and can really learn to compensate for these effects by using the same training techniques and what we have used for pre-training. This works actually pretty fast and can be done within less than half an hour. Let's have a look at the results. You can actually see the two green curves, which are our neural receivers, and the dashed green curve is the universal pre-trained neural receiver. And then when we do the fine-tuning, you can actually see half a dB improvement, roughly half a dB, using the site-specific training. This is actually shown by the solid curve. Now, the curves are actually pre-computed using a data set, but what you can see are these points coming from the live test bed. And you can see actually that the performance of the live measurements from this demo fit actually very well to what we have pre-computed. And that's a way how we can actually validate and evaluate the performance of our neural receivers in a live hardware test bed using a commercial RU in the loop.